Okay, let's dive right into a really fascinating cosmic mystery today, one that has seriously puzzled astrophysicists for years. We often look up at the night sky and imagine this perfect clockwork universe, right? A place where stars orbit in perfectly predictable, eternal dances. But it turns out the cosmos is absolutely full of surprises. Today, we are investigating what is literally a missing persons case, or, well, a missing stars case, on a massive galactic scale.
So, here is the core of our mystery. Astronomer Karim El-Badri over at Caltech noticed this massive, glaring discrepancy while observing the skies. Our universe is completely filled with wide binary star systems. These are pairs of stars that are loosely bound together by gravity, and they orbit each other at incredibly vast distances. But El-Badri realized something weird. These widely separated pairs of stars are mysteriously way less common after one of the stars ages and turns into a white dwarf. It is exactly as if the companion star just vanished into the dark. Poof, gone. So today, we are going to find out exactly why this happens.
Section 1. The Wide Binary Mystery, Cosmic Disappearance.
Now, to understand this cosmic crime scene, we first need to look at how sun-like stars are actually supposed to die. We've known for a long time that really massive, giant stars die in spectacular, incredibly violent supernovas. When they explode, they give off this massive kick that just rockets the surviving core straight through space. But sun-like stars? We've always considered them the gentle elders of the universe. The assumption was always that when they run out of fuel, they expand into these bloated red giants and they just shed their outer layers in a quiet, balanced, and perfectly orderly fashion before quietly shrinking down into a dense white dwarf.
Section 2. A star's chaotic death, uneven eruptions.
Well, scratch that assumption, because this brings us to a really groundbreaking new model by Caltech theoretical astrophysicist Jim Fuller, and it completely shatters the idea of a peaceful, quiet, stellar death. Fuller ran these massive computer simulations of the convection inside aging red giants, and what he found was completely unexpected. His model reveals that these dying bloated stars absolutely do not shed their layers smoothly, not at all. Instead, matter just churns violently near the surface, and huge blobs of gas escape unevenly. They get chaotically and asymmetrically blasted into space. And, as Fuller brilliantly points out, it's just like Newton's third law. Every time a massive blob of gas violently erupts in one direction, the star itself gets a little kick, pushing it backward in the exact opposite direction.
So, the absolutely crucial point here is the sheer scale of this process. A star nearing its final white dwarf stage isn't just burping out gas once or twice. Oh no! According to Fuller's calculations, that dying star is going to experience roughly 10,000 of these small, eruptive kicks over a period of several 100,000 years. It's just this relentless, chaotic barrage of tiny explosions happening right at the tail end of the star's life.
But we do have to remember the immense, mind-boggling size of a star. Individually, these chaotic eruptions are actually incredibly weak. Each asymmetrical burst gives this massive celestial body a tiny push of just a few meters per second. To put that into perspective for us down here on Earth, Fuller likens that speed to a slow jogging pace for a human being. It's barely a gentle nudge in the vastness of space.
Section 3. The Random Walk Effect, Building Momentum.
Okay, so you might be wondering, how on Earth can a human jogging pace possibly disrupt an entire solar system? Let's look at the math, specifically a mathematical concept known as a random walk. Think of it like this. Imagine repeatedly flipping a coin to decide whether you take a step forward, backward, left, or right. Because every single step is totally random, you might assume you just end up pacing back and forth over the exact same spot, right? Well, mathematically, that's actually not what happens. Over thousands of steps, those tiny random movements eventually compound, and you end up drifting a surprisingly significant distance away from your starting point.
And this random walk concept brilliantly illustrates exactly what happens to our dying star. Because those 10,000 chaotic gas ejections happen in entirely random directions, the little kicks do not perfectly cancel each other out. The math dictates that over hundreds of thousands of years, these tiny, jogging pace nudges compound. They build up until the dying star has literally gained a net speed of about 1 kilometer per second in a completely random direction.
Section 4. Solving the Cosmic Puzzle, Unbound Binaries.
So, armed with the mechanics of this chaotic random walk, we can finally return to our initial missing persons mystery, the vanishing binaries. Remember, we know that wide binary stars are very far apart. Because of that distance, the gravitational bond holding them together is relatively weak, and their orbital speeds are incredibly slow. So let's snap the pieces of this puzzle together. Step 1. The random kicks generate a net speed of 1 kilometer per second for the dying star. Step 2. That 1 kilometer per second kick is actually faster than the slow orbital speed keeping those two distant stars tethered together. Which leads us directly to Step 3. The gravitational bond simply snaps. It breaks. The dying star literally kicks itself out of its own solar system, leaving its longtime companion totally behind.
And just like that, the mystery of the vanishing binaries is officially solved by thousands of tiny random kicks. This breakthrough brings immense relief to astronomers like Kareem El-Badri. They now finally have a concrete, physical model that perfectly matches their completely baffling observations of the night sky. It turns out, white dwarfs aren't just magically losing their partners. They are literally chaotically pushing themselves away. Section 5. Triggering stellar collisions, violent mergers.
But hold on to your seats, because this chaotic model also makes a thrilling, brand new prediction for astronomers to hunt for. Remember, that random walk means the star shifts in a completely random direction. While most of the time it kicks the star away and breaks the wide binary apart, probability tells us that won't always be the case. In rare situations, those repeated kicks will alter the dying star's orbit and push it inward, straight toward its companion star. Instead of separating quietly, these stars will crash directly into each other. This direct stellar collision would produce an absolutely violent, massive explosion, a phenomenal event that astronomers are right now eagerly preparing to look for in the night sky, to test Fuller's model even further.
Honestly, it really makes you rethink everything we assume about the cosmos. We always thought sun-like stars faded away peacefully. But this explainer reveals that even the so-called quietest stellar deaths are actually filled with microscopic chaos. Chaos that is powerful enough to violently kick entire solar systems apart or even cause massive stellar collisions. It really leaves us to wonder, as we gaze up at the stars tonight, what other subtle, completely invisible forces are quietly breaking apart the heavens right under our noses. If your mind was just blown a little bit today, hit that like button and subscribe. Stay curious, and I'll see you in the next explainer.